Find current through 1 ohm resistor using superposition theorem. This is the given network. We have three sources, one voltage source 4 volts and two current source. So arrow mark indicates that it is a current source. This plus minus, or you can also write one circle plus minus, that is also voltage source. This is length R1 means it's a battery terminal. Length R1 is positive, this is negative. This is a voltage source and this is a current source. There are three sources are there. So just recall superposition theorem statement. Superposition theorem states that the overall response is equal to sum of algebraic sum of individual response. Here there are three sources are there. So what is the question here? Find the current through 1 ohm. So find the current through 1 ohm is, this is nothing but your load. In this load you have to find current. So the current is going to flow in 1 ohm due to 4 volts also, due to this 1 amps also, due to this 3 amps also. So we have to find if only 4 volts is acting and these two current sources are 0, then how much current is flowing here? That is the I dash. Next you have to consider only 1 amp is flowing. We have to make this voltage source is equal to 0 by short circuit. This you have to make 0 by open circuit. And due to this 1 amp, how much actually current is flowing through this? Next you have to consider only 3 amp current source is acting. And you have to make this 1 amp 0 by open circuit, this 4 volts 0 by short circuit. Remember, any source if you want to make 0, for voltage sources you have to short circuit. Okay, current source you have to open circuit. If you do reverse, okay, if you make current source is equal to short circuit, currents this due to this closed path some current will flow, not it will become 0. So in order to make no current is flowing through this should be removed or open circuit. Similarly, here if I short circuit this two terminals, the voltage value becomes 0. If you open it, then some voltage will be there between this and this. So always voltage sources should be short circuited to make 0 and current sources should be open circuited. So you have to solve this problem using three different cases. You have to find I dash, I double dash and I triple dash, and according to the superposition theorem overall response is equal to, we have to add algebraic sum of I dash plus I double dash and I triple dash, where all those are individual responses from three different sources acting at a time, only one acting at a time. Now let us consider case 1. Here we considered as 4 volts acting alone. Okay, 4 volts acting alone. Here this we have to consider. So this source, please remember here this 1 amp is open circuited, so nothing is written here. It is fully open circuited, and this 3 amp is also current source, it is open circuited. So this 3 ohms now it is become dummy because this other end is not at all connected because this is also open, this is also open. So that's why for the first case 4 volt source acting alone, we left with only this simple circuit, only this circuit, and this is also open, this is also open. 3 ohms is actually ignored because the other end of 3 ohm is not at all connected to your circuit, it is not forming any closed path, so just it is hanging. So we left with only this part. So here it is a simple circuit, voltage source in series with resistances. So current we can find out. So if you consider the first case, let us call the current as I dash. We are finding current through 1 ohm now. Same in 1 ohm, we are considering the current as I dash now. So I dash is equal to voltage divided by current. So voltage is 4. Sum of resistance is 2 plus 1 is 3. 4 by 3 amps. So it is I dash. So now we have to find out second case. Consider 1 amp acting alone. So 1 amp acting alone. So now you have to consider only 1 amp is flowing. So this is you have to short it. This source you have to short it, and this you have to completely remove from the circuit. So the circuit becomes, here it is shorted, here it is shorted, here it is fully open. And we know that any resistance in series with current source is redundant. You connect 3 ohm or 30 ohm or 1 ohm, 1 kilo current in the series, it is remain same. You know that this current will flow Redundant means nothing, but it's not going to affect anything. This 1 amp will go like this up to here. It will be 1 amp only to here. Left side of this 3 ohm up to here, it is 3 ohm. Now there are two paths. One current will flow here, some current will flow here. So I want current through 1 ohm. I want the out of this 1 amp, how much current is actually flowing through this 1 amp, 1 ohm. So this is a current division formula. Current division formula states that now it is I1 is this is main current is 1 amp. 1 amp is flow through up to 3 ohm. After the 3 ohm, we have two branches. 2 ohm is one branch, 1 ohm is another branch. Again, these two current will combine and it forms 1 amp once again. So 1 amp is going to divide between 2 and 1, and again it combines. Okay, now I want to find out how much current is flowing through this 1 amp. So main current is 1 amp. This is current division formula. 1 amp is going to divide between two branches. So I want to find the current through this 1 ohm. So you have to write formula, current division formula, main current into resistance opposite to this 1 ohm, because I want the current through 1 ohm. So you have to write resistance opposite to this. This current is dividing between this 2 and 1. So opposite to 1 is 2. This 2 ohm is resistance opposite to this 1 ohm divided. This is 1 amp. This is the main current. This is 1 amp. Resistance opposite to 1 ohm is 2 ohm divided by sum of two resistance. Sum of these two. Don't consider this 3 is redundant, because in 3 ohm no division will take place. After coming out of this 3 ohm, this division will take place. So you have to write only sum of resistance means 2 plus 1. 2 plus 1 is 3. So it is 2 by 3. It is 0.66 amps. So now the last case, this is I double dash by considering the second source. Now let us consider the third source, 3 amp source, current source. So you have to make other two sources 0. 1 amp you have to open circuit because it is a current source. 4 volts you have to short circuit because it is voltage source. Write equivalent circuit. This 1 amp open, no, that above portion will not come, and this is short circuited. Now here also it is redundant, because irrespective of resistance here, current remains same here. So this 3 amps will come to here, no division, up to here, no division. After that, this 3 amp is going to divide between these. It's going to divide between these two. So again I want the current through 1 ohm. Again I want to find the current through 1 ohm. So current through 1 ohm is, you have to write main current 3 amps. This 3 is current. Current through 1 ohm is main current 3 amps into resistance opposite to 1 amp. Resistance opposite to this 1 amp is 2 ohms. This is 2 ohms divided by sum of resistance 2 plus 1. So 3, denominator is 3. 3 will get cancelled with 3. We left with only 2. So we got individual responses from 4 volts as individual response from 4 volts as 1.33 amps. That is I dash. Individual response in 1 ohm due to 1 amp is zero point 0.6 amps. And you have to see the direction of the current. All are actually going down only. It is coming down. Okay, because in the 4 volts also positive is here. So it is coming down here. And in 3 amps also it is going down only. And in 1 amp also it is coming down. In all the cases, all the currents are going downwards only. This is also down. This is also down. This is also down only in the 1 ohm, no 1 ohm resistors. So superposition theorem states that the overall response, okay, the overall response is equal to sum of individual response. This is due to 4 volts. This is due to 1 amp. This is due to 3 amps. So it is equal to 1.33 downwards, 0.66 downwards, 2 amps downwards. If you add all these three, you will get 4 amps. This is also going down. Okay. So we calculated current through 1 ohm using superposition theorem by considering each source acting alone. When one source is acting, other two sources should be made 0. If it is a current source, open circuit. Voltage source means short circuit. This much you have to remember. Okay. Thank you.